All right, we are going to look at the last of our three basic laws, and this one is the law of multiple proportions. And so here's what it says. I have to have at least two compounds, and the two compounds have to be made up of the same two elements. So in the example we're going to look at here, my two compounds are made up of hydrogen and oxygen, so the same two elements. And it tells me that the ratio of the masses of the second element, which in this case is going to be oxygen, combined with a certain mass of the first element, which is going to be hydrogen. So in other words, the two elements that are in both compounds have to be exactly the same. That ratio of the masses is always going to be a small whole number ratio. Okay. All right, so let me see if I can't put it in mathematical terms for you. All right, so when we look at the mass of oxygen and the mass of hydrogen here, I'm taking those values directly from the periodic table. So if you want to pause the video here and pull out the periodic table that I gave you with your textbook, and you're going to look and you're going to find oxygen. And oxygen is going to be atomic number 8. And so in my first compound, which is water, there's just one of these guys. So in other words, the mass of this from the periodic table is going to be 16. When I look at hydrogen peroxide, which is H2O2, there's a 2 here. So we're going to have to multiply 2 times that 16 to get 32. All right, we're going to repeat the same thing with hydrogen. So hydrogen is number 1 on your periodic table. And so if I look at water, there are 2 hydrogens. So I'm going to take 2 times the mass from the periodic table. We get 2.016. And our hydrogen peroxide also has 2 hydrogens, so I get 2.016 here. Okay, I'll make a little note here that I took 2 times 16 to get this number. All right, so now we're going to make a ratio. In the ratio, the mass of oxygen is going to go on the top, and the mass of hydrogen is going to go on the bottom. So this is 16 to 2.016. And I want to reduce this down. So I'm actually going to take 16 divided by that 2.016. And so this tells me that there are 7.943 grams of oxygen for every 1 gram of hydrogen. Because again, any number divided by 1 is still itself. So I didn't change the numerical value that was displayed on your calculator. All right, so then here, we're going to take our 32 and divide it by 2.016 to reduce. And we're going to get 15.87 grams of oxygen for every 1 gram of hydrogen. Okay, now I want my ratio to be a small whole number. So to do that, we're going to take the bigger number. Okay, so this 15.87. Great. Because if I look at this ratio, there's 1 gram of hydrogen in both of these. So that's the first part of the law. And we're going to divide it by the smaller number so that we're going to get this nice whole number. Okay. And so when I divide, I get something like 1.997. So we're going to round this to 2. And so the ratio to oxygen in these two compounds is a 1-to-2 ratio. So that is the law of multiple proportions. So it has to have at least 2 compounds, and they have to have at least the same 2 elements in them. And the second element, which in this case is oxygen, their masses have to be a whole number ratio.